handy shortcut. So last day we looked at solving quadratics, and then I went fast, I know, and then we looked at formula manipulation. What we want to do now is get tricky with it. Oh, shut up, Mr. Dueck. Okay. The handy shortcut that I gave you, by the way, is if you have one fraction equals one fraction, you can move stuff diagonally. That's cross-multiplying with a vengeance, Thomas. That's saying, I'm not even going to bother cross-multiplying. I'm just going to rearrange this all in my head. So let's go get trig. Trig, the next page. You learn in Math 10, Sohcahtoa, which stands for sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, a wonderful little acronym. And you need to be aware that this only works when you have right angles. You also learned in Math 10 the sine law and the cosine law. This year we're going to use those a lot more. In particular, the cosine law we're going to use to analyze car crashes quite a bit, because car crashes that are only head-on are boring. Most car crashes, things bounce off at angles. So when we get to momentum, we'll be pulling out the cosine law, but I always kind of sow the grass right now so that hopefully it starts to grow a little bit. But you need to make sure your calculator's in degrees. Who is in Math 12 this year? Pre-calc. Who was in calculus this year? Sometime for all of you around, I think it's going to be around Christmas, in your math class, you're going to say, you know what, degrees suck. Radians is a much, much, much better way to measure angles. And you're going to switch your calculators to radians. You're going to have to get in the habit of, whenever you're in my physics class, switching your calculator to degrees. Whenever you're in your math class, going to radians. Okay? Radians are better, but physics we do stuff in degrees. So I got to tell you a story, but I got to pause the video. So I've told my story. Easiest way, first of all, your calculator might have a S or a R or a D somewhere on the screen. The graphing calculators, oddly enough, don't. So the easy way, Spencer, find the sine of 30. It should be 0.5. Yeah. Okay? Or on the TI graphing calculators, if you press the math button, oh, turn it on, Mr. Dueck. If you press the math button, no, not the math, the mode button, degrees should be highlighted. So you need to find on your calculator the sine of 30 and make sure it's 0.5. If it's not, you need to change the mode. And if you don't know how to do that, now is your time to ask me. Everybody's in degrees? We're all happy, Joy? Okay. So we solve. A, solve. It's a triangle. It's a right angle triangle. I can get tricky with it. I'm going to label the sides. I think I told you last day, I am always minimum work for maximum buck. I want to be as organized as possible with as little writing as possible. So one of the things I've gotten into the habit of, often when you give me a triangle to solve, just because it makes me feel better, I'll color in the angle to make it stand out so I know that's the one I'm looking at. I've written something down, it's no longer blank. Then I'm going to label the sides. I'm going to label the sides. Nick, is there a right angle in this triangle? Say yes. So I can use Sohcahtoa. Hey, that 13.1, opposite, adjacent, or hypotenuse? Opposite? Yes? That X, adjacent, or hypotenuse? Now, I'm going to disagree with some of your math teachers. I know some of your math teachers tell you to label all three sides. I'm going to say something I don't say very often. I don't think that's the best teaching. Right now, isn't it clear that it's O and H? Which trig function? Sine. Sin is when you swear in my class. Sine is the trig function, just letting you know. If you do this, you've done more work, and I don't think it's as clear. Because now there's an A gumming things up. So I never label stuff unless I have to. I think that's a win-win. Which trig function? What always goes next to the trig function? The angle. What's the angle this time? 58. Equals opposite over hypotenuse. Oh, Mr. Dueck. What, Dale? Mr. Dueck, if you do that, that's one fraction equals one fraction. Why, yes it is, Dale. Mr. Dueck, it seems to me that stuff can move diagonally. Why, Dale? Yes, it can. So if I hear you correctly, Dale, and I think I do, what you're saying is to get the X by itself, I could move it to there and move that to there. In my head showing no work, I'm good with that, Mitchell. If you can, great. In fact, I would go x equals 13.1 over Dustin, I tend to go to that, my next line. See it? We kind of this is cross multiplying with a vengeance, Jordan. Which is what? Now I go to my calculator. 15.5? Not that I don't trust you, but I don't trust you. 15.5, I disagree. I think 15.4. Where? No, that rounds to a 5, but if you start there, that's a 4 next to it. And we decided, and if I didn't say it last time, I'll say it now, Kiowa, 2 or 3 sig figs for everything. So I'm going to go, I would accept 15, but I would probably cringe a bit because that's rounding off a bit too much, Sean. 15.4, 15.5, I'd put a little frowny face, and if it became a problem, I'd take a half mark off to get your attention. Okay? I will always take a half mark off if you forget units. I'm fussy on that. What are the units here? Meters. What I want you to build, Raj, as your final check, you check 2 things, sig figs and units, and then just get that habit. Does that answer make sense? Well, it's the hypotenuse, so it should be the longest side. If, Kiowa, we had got an answer of 9.2, I'd be saying, wait a minute, 13.1 is longer. I've done something wrong, because Dueck makes up reasonable numbers. He doesn't just make stuff up that doesn't work. B. Triangle? Yes. Travis, is there a right angle? Yes. Then I can use Sohcahtoa. I tend to, just because it makes me concentrate, that's the angle I'm talking about. I always tend to color it in. You don't have to, but I do. And now I'm going to label my sides. I see a 12.6. That 12.6, opposite, adjacent, or hypotenuse? I heard someone say opposite. They are correct. What about that 3.7? Which trig function? What some of you were doing this summer? Tan? What always goes next to the trig function? The angle. What's the angle this time? A variable. And traditionally in math, for our angle variable, we tend to use the Greek letter theta. A 0 wearing a belt. The same way if you see x and y, usually it means you're graphing x and y coordinate. The same way for Pythagoras, which 3 letters do we tend to use? A, B, and C. It's, Thomas, a shorthand way of letting people know what context we're in. So if I ever see a math paper and I see a theta, that probably came from an angle somewhere. Okay. Equals opposite over adjacent. Now, normally we try and get the theta by itself. We have the tan theta by itself already. I can't rearrange this. Instead, here I have to let my calculator do the work for me. Who remembers how the heck can I find an angle once I have the trig function? Joshua. Yeah, I was right. So, Josh, okay? In English, he even brought the European term. So in English, in North America, we call it inverse sine or inverse cos or inverse tan. I like arc sine and arc tan and arc cos better because it sounds cooler, arc, and I think it's clearer, but you're going to hit the shift button on your calculator or a second function button on your calculator or the inverse button, whatever that top left button is called on your calculator. So on mine, it's second function, tan, and mine automatically opens up a bracket. If yours does not automatically opens up a bracket, and some of your calculators won't automatically open up a bracket, then what you'll need to do is open up a bracket and then type in 12.6 divided by 3.7 and close the bracket off. And you get 73.6 degrees. 74 degrees, I'll go to 3 sig figs. About, Kyle, we're going to be doing a lot of trig this year. About 90% of our trig will be Sohcahtoa right angle. But I also know most of you have seen that since grade 10, and I know from experience that by the time we get to the second unit on forces, you will get so good at the trig part that you'll find shortcuts and just start doing it in your head. I know from experience what kids struggle with the most is going to be the sine law and the cosine law, the non-right angle trig. Kevin. Yes? So, next page. It says solve for C, and then Max, it says use what?
Sine law.
What if I hadn't said that? What if that wasn't there? What does anybody know? What's the easy way that you can tell just at a glance? This is a sine law question, not a cosine law. First of all, is there a right angle? So it's not Sohcahtoa.
Is it SAS?
Nope. That's actually for cosine law, but there's an even easier way, okay? Here's what I do. In my head, I draw this line here, and I ask, do I know both the angle and the side? I don't, so say no. Then I draw this line here, and I say, do I know both the angle and the side? Say no. I draw this line here. Do I know both of those? I say that, I call that, this is my own term, Jordan, a pair. If you have a pair, it's a sine law. If somewhere, if you draw those, and you can do those in your head real quick, if on one of those three lines you know both the side and the angle across from it, I'm telling you it's sine law. Otherwise it's cosine law. And there's ways to determine that it's cosine law, but honestly, I just check for sine law first, and it doesn't work. It's either cosine law or it can't be solved, and I know Dueck's not going to give me one that I can't solve. In other words, no, cosine law. No, oh, see the pair? Sine law. No, cosine law. No, cosine law. Yes, SAS and SS, but I'm much more pragmatic. I'd like something and just that's quick and dirty and works. So this is the sine law. What is the sine law, you ask? What is the sine law, you ask? What is, I'm so glad you, oh no, wait a minute. You don't need to ask. It's on your formula sheet. It's on the back page where the writing is small, where there's a bunch of math stuff. So you don't need to memorize this, although you can, because it's not a tough one. It's sine of big A over little a equals sine of big B over little b equals sine of big C over little c. But you never use all three of those. You only use two of those, Kyle, at a time. I think in this case, I'm going to use the one with the A and the C in it. I think I'm going to have this. Sine of big A over little a equals sine of big C over little c. Now we plug and chug. Sine of, what is big A? We decided that we would name angles with capital letters and the sides across from them with small or lowercase letters. So big A is going to be 48 degrees over equals sine of 72 degrees over little c. Oh, Mr. Dueck. What, Dale? Mr. Dueck, this is one fraction equals...
One fraction.
Dale, are you saying that because this is one fraction equals one fraction, stuff can move?
Yeah.
You would be right, Dale, my friend. By the way, that's your cue for a while. You with me? Okay, you're on the road. You would be correct. So if I hear you, you're saying because the C's on the bottom, I don't like it there, I could move the C to the top, like maybe right there. I can move the 6.2 right to there, and now it's on the top. And where would the sine 48 end up? Down. In fact, I think what you're saying, and I think you're right, is that C is going to be 6.2 sine 72 all over sine 48? Is that okay? I did a lot there in one step. That's just cross multiplying with a vengeance. That moves, that moves, that moves. And now I go to my calculator. 6.2 sine 72 divided, oh, I got to close the bracket off on mine, divided by sine 48. If you're not following along on your calculator, I'm telling you, you're setting yourself up for ugliness. Every year, I got some kids that have all the right numbers on the test and the wrong answers, and I just, oh, they didn't follow along in class. This, during the lesson, is when you want to make your mistakes. Alex, I got 7.93 for 7.93. Yes? Woohoo! Units, centimeters. So I wrote, we use the sine law when we have a pair. Do you guys understand what I mean by a pair? The angle and the one across from it, not beside it, the one across from it. Come on. I want to stop. Right there. There we go. And that's how I know, nice yawn, you going to be awake? Clay, still learning names. Ah! No, nothing? Got back row there, he's awake at least. I missed Clay though. Get ready for it, Kyle, it's a long day. So, this is how, go ahead, hustle back. I would glance at this. I go process Sean of elimination. Is there a right angle? No, so not Sohcahtoa. Is there a pair? Boom, boom, boom. Nope, that is cosine law. Has to be, or it's not solvable. What is the cosine law, you ask? I'm so glad you know what? You don't have to memorize that one either, although, Raj, I'm going to give you a way that you sort of can. I'm going to make the assumption that all of you have Pythagoras in your back pocket. The cosine law starts out like Pythagoras. Hang on, let me pause the video here. I got somebody at the door. Give me a second. So, cosine law. What is the cosine law? It starts out like Pythagoras. It's, whoa, did this thing again, didn't it? I need to go click, come back, and then every once in a while it just vanishes. But if, oh, I want to do that. If I do, and now it's all back again. Go figure. Magic. It starts out like the cosine law. It's sorry, like the sine, like Pythagoras. It goes like this: c squared equals a squared plus b squared. You've seen that, I think, since grade 8. I think that's when you first do Pythagoras. And here's the only part that I bothered memorizing. I know it goes minus 2, same two letters, AB, cos, big C. The one that's on your formula sheet, is it the one that has the little C by itself? Oh, which one did they give you? Does it have the A by itself? Is it A squared equals B?
Cosine law is c squared equals a squared.
So it's got the C by itself. Okay. Here's what, because here's what I've remembered. Okay. See this letter? What letter is that? Same as that one. That honestly, I don't even say. Oh, that letter and that letter are the same. So in other words, if you want the A by itself, it's going to be A squared equals B squared plus C squared minus 2 BC cos A. Or B squared equals A squared plus C squared minus 2 AC cos B. I've memorized the pattern just so I don't mix it up. Let's use it. What are we being asked to find in this triangle? Little a, little b, little c, big A, big B, or big C? Little c. Oh, so I can conveniently then, Dustin, use this one. So it's going to be plug and chug. Here we go. It's going to be c squared equals. Now, once you've decided what c is, it doesn't matter what you let Kevin A or B be as long as you're consistent. So, Dustin, you might let A be the 8.4 and B be the 6.2, where Kyle, you might let A be the 6.2 and B be the 8. We'll get the same answer. Technically, A should be 6.2 squared. Plus, technically, little b should be 8.4 squared. But you can really be sloppy. Minus 2 6.2, 8.4 cosine 65. And now, Clay, you're right. If you have a half-decent calculator, you should be able to type this in one fell swoop. And I do. So I don't show any more work. I go 6.2 squared plus 8.4 squared minus 2 times 6.2 times 8.4 cos 65. The most common mistake here is kids think they're done. What was that? Yeah, and Spencer said, we found c squared. We got a square root. And Spencer, the reason this is the most common mistake, when we start using the cosine law, it's going to be analyzing car collisions, and you'll have done about 9 lines worth of work. And you'll get to here, and you'll hit equals, and Jason, you'll be so proud. You're like, finished. And you'll forget to square root. It happens every year. So I will lovingly beat that into you when we get there. And this is where you want to know where your answer button is. I go square root, answer button. Most of you, your answer button is shift equal sign. Some of you, your answer button is shift here. Spencer, yours is there, right? You figured that out? It's way less typing to use your answer button and way less error. That's like a win-win. I get 8.06. 1, 0, 2. Oh, no, 2 or 3 sig figs. I would accept 8.1. I would accept 8.06. I'd be grumpy at 8.0. I'd take a half off. And I heard someone murmur units. So when do we use the cosine law? Honestly, Max, well, I don't have a pair. But if you want a more specific, I'm going to say here, when we have no pair, but you did bring it up. We use the cosine law when we have side, angle, side, a side, an angle, and a side. Or when we have side, 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 3 sides and no angles. But to me, that's extra memorizing. Why don't I just have sine law pair, otherwise cosine law? Then I don't have to memorize a whole new situation. I went on my rant about how much I dislike memorizing useless stuff, right? I did the Feynman story and all. Yeah? Okay. I did the Feynman cat thing. Yeah. Okay. Apparently someone has a trouble memorizing things that I've said, but that's okay. Turn the page. I glance at E. What do you think? Sine law or cosine law? I heard both. Which one? Convince me. There it is. Sine law. So, you ready? I know on your formula sheet it says sine big A and sine big B and sine. I haven't even memorized that. Here's what I know. The sine of the angle that I know over what's across from it, its side, equals the sine of the mystery angle over what's across from it. That's really what the sine law says. Dale, is this 1 fraction equals 1 fraction? Yeah. Now, normally then I would say stuff moves. Oh, yeah, I guess what I can do is this 14.6 can move up to there and it'll vanish. But that won't give me the theta by itself. That will give me the sine theta by itself, which is the best I can do right now. The best I can do right now is to say sine theta equals 14.6 sine 51 all over 12.3. Now what? Sorry? We're going to, here's what, because I'm, again, maximum bang, minimum buck, minimum errors. I'm going to actually type this whole thing into my calculator. In other words, I'm going to go 14.6 sine 51, close bracket, divided by 12.3. That's the sine of theta. Now what? I have to inverse this. Oh, I have that handy-dandy answer button. Inverse sine, arc sine. By the way, the symbol for inverse is that stupid little -1. Worst symbol in math ever. If you made me the president of the world for one day, one of the things I would change is I would replace the -1 as an inverse. I would put a Greek letter there or an I there because it looks too much like an exponent. And everywhere else it is an exponent except right there. We could have done better. Usually we're pretty good in math notation. This is one time we botched it. So shift, sign, answer. And I get 67.3 degrees. By the way, can I be a little bit nerdily fussy? Look up. If you did this, I would give you a frowning because what you're saying is that sine of theta equals 67.3. Sine of theta doesn't equal 67.3. Sine of theta equaled 0.922. Put it on a separate line. Theta equals 67.3 degrees. Would you take marks off? No, Kiowa, probably I wouldn't, but I would write a frowning face there and I'd give you the frowning of a lifetime. It's, bad math matters. Let's do it right. 2 more. F. Sohcahtoa, right angle? No. Sine law, cosine law. Got to be cosine because there's no pair. I think in terms of all the literature and strategies that I've read, that's about the minimum amount of memorization that keeps it straight. There's all sorts of other ways and you can use them, but to me, pair, no, cosine. Or it can't be solved, but I know that my teacher's not going to give me one that can't be solved. I do that. Do you remember I said A and B are fairly interchangeable? I'm so lazy I don't even bother labeling A and B. You can, but all I got to get is the C correct because it's going to be C squared equals A squared plus B squared minus 2AB cos C. How do I know that? It's on the formula sheet. You find it? Yeah. And I know C is what I'm trying to find. So, Clay, my next line, C squared is going to be, what do you want A to be? 78? Sure. 119? Sure. All I know is it's going to be both of those. Squared. Minus 2, both of those. Cos 38. And as Spencer has reminded us, make sure we don't forget to, at the end of this, square root. By the way, don't try and put this all into one big square root. I've tried that. The ugliness is not worth the keystrokes you save. So I always go 78 squared plus 119 squared minus 2 times 78 times 119 times cos 38. And then I just go square root answer button. Is there anybody who can't find their answer button? I should have asked that. Because you're going to use it a lot this year, believe me. Everybody's got it? And you get 74.9 centimeters. If you're not getting these, once I say get to work, call me over. It's almost always one of 3 or 4 calculator typos, and we can fix that. Last one. Oh, got Kohei there. That was good. Sohcahtoa, right angle. That looks close where the theta is, but they might be trying to trick me. I can't assume that it is. Sine law?
No, cosine.
Okay, so, sine law? No, that's cosine. Okay. What's weird about this one? We're trying to find an... That's right at the cosine law anyhow. We're trying to find, Amelia, an angle. In fact, what we're trying to find is, there's C, big C. So as soon as I do that, which one is little c, the 7, the 10, or the 12? I'll do that. I don't label any more than that. And, because I'm a nerd, I'm going to rewrite this equation. I'm not going to plug in numbers yet. I'm going to get this by itself. How? Well, first I'm going to deal with these two things. What are these two things doing on this side? Adding, subtracting, multiplying, or dividing? How will I move them over then? So if I hear you correctly, the c squared, little c squared, drops down like a domino, and you're saying there's going to be a minus a squared and a minus b squared. I totally agree with that. Equals. Don't write this next bit down. You can, but I'm going to challenge you to just do this in your head. So don't write this next bit down. The minus, the 2, the a, the b, and the cos would drops down like a domino. What are we trying to get by itself? The cosine of c, and then we're going to have to go inverse. What's in front of the cosine of c? A negative, a 2, an a, and a b. See it? What are they doing to the cos? Adding, subtracting, multiplying, or dividing? Multiplying. So how will I move them over? Most common mistake, kids want to add them over because they see the negative. So you know what? This is what you can write down. The cos c would drop down, but the minus 2ab would be there. That you can write down. I don't think that's on your formula sheet. And I'll be perfectly honest, I'm only doing that because I'm a math nerd. You can actually survive this whole year without having to use the cosine law to find an angle. There's only one question where it's slightly quicker, but even then, it's almost just as easy to cleverly break it up into two components and go Sohcahtoa. But I'm a math nerd. Now let's plug and chug. The cosine of big C is going to be little c squared, 12 squared, minus 10 squared, minus 7 squared. Mr. Dueck, I went minus 7 squared, minus 10 squared. Doesn't matter. A and B are interchangeable. I wasn't kidding. All over negative 2, there's going to be a 10, there's going to be a 7. Quick question, Clay. It might be a good question. You okay? Notice there's a fraction here. Is there more than one number in the top? Brackets. Is there more than one number in the bottom? So I'm going to go bracket 12 squared minus 10 squared minus 7 squared. I'm going to close the top off. I'm going to go divided by. I'm going to go bracket negative 2 times 10 times 7, and I'm going to close off the bottom. And what the? Oh, that's not theta. What have I really got by itself? Cosine of angle C. If that's the cosine, how do I find where angle C came from? Nope. How do I go backwards to find the angle? Inverse cos. Shift, cos, shift, answer button. And you'll see I was sneaky. I think it's really close to 90 because I wanted to tempt kids to use Sohcahtoa even though they can't. Isn't it like 88 degrees or 87 degrees or 89 degrees or 91, something like that, yeah? Oh, there you go. Now, Kiowa, let's come full circle. I'm going to round to there. What's next to the 9? A 5. So this would round up to a 0. This would bump up by 1 as well. That's what you were accidentally doing before, but you're starting too far away and just bumping all the way up, right? So this is going to be 88.0 degrees. That little slanty thing is the symbol for angle. Angle C is 88.0 degrees. That's the cosine law. The sine law. Sohcahtoa. Formula manipulation. Getting tricky with it and getting quadratic. So for your practice, my children, my angels, is I handed out last day, I think, this thing here called the Basic Math Review. Did I hand it out? And Brendan, I think I might have forgotten to give you one. I screwed up. I realized after I photocopied it, every other year, I haven't photocopied it 2 to a page, and it's been bigger. It's been big enough that you could show all your work on it. You can, if you want to try showing all your work on there, you can. Or if you want to just do it on a piece of paper and staple it to the back, you can. I did attach the answers on the very, very last page. They are there.